Well, hello everyone, and how you doing today? I just thought I'd play around today. This is just going to be a fun video. We're going to try out an amplifier here, and you can see I have my Adcom preamp set up, and we have the amplifier plugged in, and we're just going to listen to how this sounds. And I have the my good microphone hooked up at the same time, so we can record this, and then I'll kind of overlay that audio so you can hear how this new amp sounds. So let's hit start and just little YouTube library jazz. So what do you think? Doesn't sound too bad. Well, I got news for you. It's not this Carver. And it's not, obviously, the Pioneer. Do you want to see what it is? Here's our new power amplifier. You're looking at it. That's the whole amp. That's it. And it's running on 5 volts. That's the whole amplifier. Little Class D. Bought it on eBay for, I think, $2 American or something. If that. Unbelievable, isn't it? So let's let's take this amp over to the bench and do a couple other tests, but you can see what it sounds like. Okay, for comparison's sakes, we're going to do the same test now with the Carver Cube, and obviously you're going to hear a difference now, but it's surprising how good that tiny little postage stamp works. So let's listen to the Carver now, which is actually a very, very nice sounding amp with these Klipsch speakers. Now, what I'm going to try to do is I'm going to, of course, I'm recording these as a lossless thing, and then I'm going to try to upload them lossless, high bit rate onto the YouTube video, so we get as close of a representation as we can. But I just think this little tiny amp is really surprising how it sounds. So let's head back over to the bench. Okay. We now have this thing hooked up on the bench, and as you can see, it's quite a crazy hookup, and let's talk a little bit about why. This is a Class D amplifier, and it's not exactly the same kind of Class D setup that you would see in a more commercial sold amplifier, like for instance this Lepi or however you want to say it, the LP2020. This little right up here would help if I got you in the frame, huh? This one right up here. It's just a little Class D amplifier, and there's some things going on with it that we do not have going on with this little amplifier module down here. And one of the things that's a weakness of this is this does not have a filtered output. Now, what do I mean by that? Well, because this is a Class D amplifier, the amplifier is always putting out a signal. And what I mean by that is in order for a Class D amplifier to work, you have to have it's kind of like a carrier signal, I would say. And again, I'm not going to get real deep into Class D amplifier theory. There are a zillion videos out there on them. But essentially what's happening is you're setting up a continuous square wave pulse train, and then you're pulse width modulating the duty cycle of that pulse. And that modulation is what actually carries your audio. Now the problem is that if you don't filter that carrier signal out, or that oscillator signal out, it's going to go out to your speakers. Now let's demonstrate what that looks like. If you look right here, this is directly on the speaker output terminals of the board. Up here is where my scope is connected, and we're going to use the big scope here so we can see nice and clearly. And when I apply power to the amplifier module, you can see these funny looking square wave pulses. And what that is your carrier signal. Now on this particular module, if you look, this is real voltage, and it actually has the capacity to carry real current. So here's your 0 volts, here 2 volts per division, so you're looking at plus and minus 4 volts on there. And I don't have it really well connected on there. There's some reasons that this is not looking very square and straight. We can get into that in a little bit. But you can see that. And if I were to connect this directly to our little dummy load down here, which is our 8 ohm resistors, you would be applying that voltage directly to this resistor. And of course, wherever there's voltage and resistance, there's going to be current. So you're actually going to be drawing a lot of current through this circuit without any signal on it. So that's why with this particular amplifier module, you can't just connect a DC resistor as a dummy load, because it will overload this little chip and it will cause it to overheat, and it will also not allow you to see what's going on with the signal. Okay, now if I put a signal on there, I'll show you what happens up here, and this scope's not going to be able to deal with it very well, but we're putting a sine wave into the amplifier right now, but you can see how it's modulating that. That's what's going on. So there's really, you can't get a very good measurement of power that way, can you? So what you have to do is you have to put in a common mode filter network to filter that out. So what I have on here is just a couple. These are not resistors. These are actually inductors. I have a set of inductors and a set of capacitors, and I just kind of drew this really quick on a piece of paper, and I'll show it to you. So essentially what we have is on each of the speaker terminals on the output, we have one of these coils, one of these inductors, and then a capacitor going to referencing to ground. And what this is going to do, and it has to be this way, you can't just do an L network because of the way the circuit is designed on this particular chip. And what this is going to do is this will allow the low frequencies, the audible frequencies, to pass through this little network, but it will snub out or block any of the frequencies above that. This is about a 200 kilohertz carrier signal. So that square wave you were looking at was running right at about 200 kilohertz, and then all they did was vary the duty cycle of that 200 kilohertz pulse with your audio. So that's what we're going to do, is we put this in there, and there's your capacitors. And if I take my probes now and move them from the output of that little board to the speaker load itself, our dummy load, and we look up here, you can see there's absolutely no noise whatsoever. And if I turn on my sine wave. Now I'm going to have to reset this. So give me a second. I'm cheating. I'm doing the auto set, and that way I don't have to try to fiddle around with the mouse on this thing. But you can see, let me change the trigger a little bit. There we go. Come on. That's the finicky thing about this is there you go. That's about as good as I can get it to lock right now as it sits. But you can see we get a nice clean sine wave now. And that's because that filter is filtering it out. So that's a little thing you need to know if you're working with these little modules. And a lot of these little small modules are built like this. They don't have the filters. Now, that little PAM amplifier I showed you earlier has this network built into the circuit. So on the circuit board, they actually have these things put in there. And these are not the correct values. I used what I had on hand, but actually you can mathematically calculate the network, and it's very dependent upon the design of the amplifier itself, the load impedance that you're putting on it, so you know your speakers and your wires and all that, to get this to be optimal. Because what's going to happen is this filter will have influence on your audio frequencies at different frequencies, so it could cause the amp to either have distortion, harmonics, or not a linear. It won't be a flat amplifier. It'll suppress the different frequencies. So this works pretty well, but it's not perfect. And if we tried to do a frequency sweep, you would see what I'm talking about. Now, question: why, when I connected this directly to those great big Klipsch speakers, why did it not hurt the speakers? Because I was putting all that voltage on there. Why was I not afraid that it was going to kill my expensive Klipsch speakers? And that would be a very good question to ask. Well, I'll tell you why. Let's take a look at the paper again. If we look at a speaker, what is a speaker but an inductor? So you have an inductor, and it's wrapped around a magnet, right? And that inductor is suspended with reference to the stationary magnet, and by inducing current flow through that coil, it causes the coil to oppose the magnet and causes the speaker to deflect. Well, at the heart of this, you have an inductor. And what's happening is that 200 kilohertz, when you apply that 200 kilohertz pulse to the speaker coil, the speaker's not going to see that, because if you remember from, well, if any of you did, from electronics, Eli the Iceman. And what this is telling us is in a coil, L, the voltage always leads the current. And what that means is an inductor is always going to try to oppose changes in current. So even though the voltage is applied across this from those pulses, there will be no current flow because the inductance of this coil will oppose that current. So essentially what it's doing is it's acting like its own little filter. Now, this we can get away with because this is such a tiny little amplifier. It has a maximum rail voltage of 5 volts. So really those little pulses are tiny with respect to a big speaker coil. But this is not something that you would want to try on the larger Class D amplifiers, the high wattage ones, and you would want to put those common mode filters in there. Now, another inherent problem I ran into with these little modules is, if you notice, there's a little transformer here, and actually it's something, again, I just pulled out of stock that I had. It's not the right one, but this is just a transformer, an isolation transformer, and what it's in there for is my actual test equipment, my signal generator. If I connected the negative terminal of the signal generator to the negative terminal of the input of the amplifier, it would cause the amplifier to oscillate. There was some sort of a ground loop, and it would cause it to oscillate. Probably something has to do with the power supply that I'm using on this and the power supply in the signal generator. So by putting this in, I'm just isolating those grounds, and that's why I had to do that. If I put that on there, again, you'd get all kind of garbage on the output. So these are interesting little amplifiers. As you can tell, it sounds really, really good on a big set of speakers even. You're getting approximately, you know, 1.5 watts or so of usable power into an 8 ohm load, and a little bit more into 4. But what I will tell you is, if you don't have one of these filters on there and you try to connect this directly onto a dummy load resistor, this will get very hot very quickly, because basically it's dumping its full rail voltage right into this resistor, because this is resistive. It's not reactive. It will not oppose the current change, the change in current, like a speaker coil will. So you really can't get that measurement we just did without that little filter network. So just something to be aware of when you buy these little modules. This is just one example of these kinds of amplifiers. Alright, so taking a look at this little thing, you can see it's a 3-watt Class D audio amplifier, and it only runs on 5 volts, and it's 3 watts at 10% total harmonic distortion, which is not very good, on a 4 ohm load. And I'll tell you, at 4 ohm loads, these things will get hot. They're really better with an 8 ohm load if you're going to do that. So just something to know. Now, the typical application is kind of what that little circuit board is. So you can see there's hardly any components. Some little tiny capacitors and resistors, that's it. And if you look at the board itself, take a look, nothing to it. Not much to it at all. Now, a couple of things. If you want to look, there is a block diagram in there, if you want to stop the video and look at it. But there is thermal protection and some things, and overcurrent protection. And if you do short this out, it will go into shutdown, and the only way to get it out of shutdown is to take power away and put it back on in some instances, but it won't hurt the amplifier. So it's actually a pretty stable little amp. Now, the next page I'm showing you is, they kind of show you that it even tells you here what I was just talking about. If you want to test this, you have to set up this little network in order to be able to even test it properly. And the way I'm doing it with the dummy load and the scope is even a little bit different yet. But you can see they talk about it in here, and I'm not going to waste a lot of time going over all of this. And then they talk about EMI and how to filter that with the ferrite beads. And again, on this particular little amp that you buy, they don't put any of that on this little board. It's just the very simple amplifier, and it's really designed to really connect pins to the bottom of it. I'll show you one that's not connected to anything. Let's see, here's one. And it's really just designed to put pins right through here, and then you can mount it to another board kind of as a piggyback board, and then put the rest of the components around it. So there you go. Just an interesting, I just thought this was interesting for how tiny it is, and actually at low power how good it actually sounds. You know, I was very impressed, and you just have to be aware of those. Now, one last thing that I don't think I mentioned is, because of the way this amplifier is designed, okay, it's like a BTL, I think is what they call it. The way this thing is designed, the outputs, the speaker output terminals, you can't connect the grounds together. You have to keep them separate. So once again, we're back to, if we're going to test the output of this with our scope, You really don't want to use your negative terminals of your scopes on both of the negatives of the speaker terminals, or you can cause problems with the amplifier. So once again, you will either have to use your scope in, well, use a 4-channel scope in differential mode, or you would have to use an isolated differential probe for each channel, or something like that. But you cannot connect your grounds together, the negative terminals of the speakers together. That's a no-no. So these are a little bit tricky to work on, and they're a little bit tricky to test, as you can see. And it's just a function of Class D amplifiers. They are finicky about things like that. The higher end ones have circuitry built into them, but I thought it would be cool to show you this one here without that, so you can kind of see how it works behind the scenes. So this was just a quick little video. I didn't go crazy on it. It's just something for fun I was playing with. Thought you might enjoy it. So again, thank you all for watching, and any questions or comments, feel free. My information's on every one of my videos. And until next time, I wish you all peace, joy, happiness, and good health in your lives. And just so you guys know, on that same topic, I may have a little bit of slower outcome of the videos here in the next month or so. Work is very busy. I'm going to be going in for some minor surgery here in another week. So I have to get a bunch of things at work taken care of prior to that. And then I'll be back at it. It's nothing serious, so don't worry. But just going to be a little bit busy for a while, so I'll try to do a couple here and there when I get some free time. But if you don't see any videos on with any regularity, that's why. Anyways, take care and be well, everybody, and we'll see you next time.